Here's an example of a carbon-carbon bond-forming reaction via alkylation of an acetylide intermediate. A reaction such as this one can also be referred to as a carbon-carbon chain extension reaction, since we're extending the existing longest continuous chain by some number of carbon atoms. It is a two-step reaction. In the first step, we add sodium amide, which is a strong base, in anhydrous liquid ammonia. The base serves to deprotonate the terminal carbon atom. This hydrogen is slightly acidic, of a pK of about 25. So the mechanism of the first step involves deprotonation, so as the bond forms between nitrogen and hydrogen, the sigma bond between carbon and hydrogen breaks heterolytically with 2 electrons from that bond going onto the sp carbon atom. Our resultant intermediate is an acetylide anion with a full negative charge on a terminal carbon, and this ion is stabilized by sodium counterion. This acetylide intermediate is both a base and a nucleophile. We need, in order to alkylate or add alkyl chain to this intermediate, we need anhydrous conditions. If water were present, the very basic carbon atom here would deprotonate water and reform carbon-hydrogen bond. Let's take a look at step 2. In step 2, we add an electrophile in the form of an alkyl halide. As we recall, the bond between carbon and halogen is slightly polarized in the direction of the halogen, inducing a dipole moment. So the electrophilic site in this alkyl halide is carbon atom connected to the bromine. Nucleophilic attack involves a backside approach by the nucleophilic carbon onto the electrophilic carbon, and the carbon-bromine bond breaks heterolytically as the bromide, the leaving group, is expelled. So this second step is the carbon-carbon bond-forming step that will allow us to extend the chain. The product, and to help us visualize the product, we can always number the carbon atoms in electrophile just to keep track of them. So we have 5 carbon atoms in the longest continuous chain of the electrophile. And the product will be our cyclopentyl, triple bond, methyl group. And then we draw the new bond, which is the bond between sp carbon, this bond here, and carbon number 1 of the alkyl halide. So this is carbon number 1, 2, 3, 4, and 5. And we fill in the missing pieces, which are the methyl group at carbon number 2 and methyl group at carbon number 3. We flip the alkyl halide horizontally so that the right-hand side looks a bit different, because we made the bond between the terminal carbon of the acetylene and carbon number 1 of the alkyl halide.